So then I go to 30 degrees. I skip a line and I go to 60 degrees. Our next one would be 90 degrees. Then we have 120. Skip a line and we have 150. 150 plus 30 is 180. 180 plus 30 is 210. Skip a line and we have 240. 240 plus 30 degrees is 270. Plus 30 is 300. Skip a line and it's 330, and we're back at 360. So all those are 30 degrees. Now the lines I skipped are just 15 degrees away. So if this is 30 degrees, add 15 and you have 45 degrees. 120 plus 15 is 135. Then we go down to 210. 210 plus 15 is 225. And finally, 300 plus 15 is 315 degrees. And why you might want to know degrees first, if you forget any one of those values and you know how to convert from degrees to radians, you can actually, it's going to take a little bit more time because you're converting, which takes a while. It's much better to have these memorized. But if you ever get stuck, 45 degrees, you can just change it to radians, which would be pi over 4. If you multiply that by pi over 180, which is how you convert degrees to radians, for those that forgot. All right, so that's our full unit circle. So with the unit circle, you should have all three of these values on your unit circle on the test, because all of them are going to be relevant. In order, they're going to go cosine, sine, and tangent. So once again, your cosine is your x values, your sine is your y values, and that one that goes on the outside is tangent. Once again, if you forget your tangent values, you don't have them memorized, you can recognize that tangent is just sine over cosine. So in this case, that would be square root of 3 over 2 divided by 1/2, which does in fact equal square root of 3. So tangent doesn't have to be memorized, but there's such few it's just square root of 3 over 3, 1 and square root of 3 that you have to add to it. It doesn't take long, but sometimes you forget which one goes where. So just remember it's sine divided by cosine. As soon as you get one of those values, then you know the pattern. It's over 3, 1, square root of 3, and then I'll repeat square root of 3, 1, square root of 3 over 3, square root of 3 over 3, 1, square root of 3. All right, so that is our full unit circle. So now let's do some unit circle values. These first two shouldn't be that hard, I hope. The first thing says, what is the sine of 60 degrees? That means you just go to your unit circle, find 60 degrees, and figure out which one of those is your sine value. Well, that's the second one. So that is going to be square root of 3 over 2. So you went from degrees to a value that does not. So you go from an angle to one of these square roots. Our next one is cosine of pi over 3. That's in radians, so we just need to find pi over 3, which is the exact same thing as 60 degrees. Now we just need the cosine value there, which is 1/2. So that is going to equal 1/2. I don't have a lot of those because you should know how to read a unit circle. If I give you an angle, you just find that value, whether it's cosine, sine, or tangent. When it starts getting a little more difficult is when we do inverses. That is just going the opposite direction. But what makes inverses hard is that if you don't remember where those inverses live, you're going to make mistakes. So this one is sine inverse of negative 1/2. That means you're going to go to your unit circle and find out where does sine equal negative 1/2. Well, the problem is it equals negative 1/2 here, and it also equals negative 1/2 here. It does not have two answers. There's only one of those two angles where it's negative 1/2. So that's where we have to add something to our unit circle or to kind of our memory banks. And that is where we write cosine. That cosine, that cosine I have up there tells you what quadrant your inverses are in. Cosine's in quadrant 1 and 2. Sine inverse is only in quadrant 1 and quadrant 4. So that means although at 7 pi over 6 our sine is negative 1/2, I can't use it because sine inverse doesn't exist there. Sine inverse only exists in quadrants 1 and 4. So that's the only place I need to look. So that means I am looking here, because my sine value there is negative 1/2. When you're doing your inverse, your answer is always going to be an angle. So either in degrees or radians. If you have an inverse, your answer is always going to be an angle. Always. All right, so our sine value is negative 1/2. However, I'm going to tell you right now, the answer is not 11 pi over 6. Does anyone remember why it's not negative, or isn't 11 pi over 6? I almost said what the actual answer was. Yeah?
Because you can't go over into the answer, so you have to go the opposite direction, so it's going to be negative pi over 6.
It's going to be negative pi over 6. So what Liv said is basically, to get there, I'd have to go all the way around here to get to 11 pi over 6. But none of this actually exists. So you can't go through somewhere that doesn't exist. So instead of going that direction, you have to go straight down, which gives us that negative pi over 6 or negative 30 degrees. So sine of negative 1/2 is negative pi over 6 or negative 30 degrees, depending on what I ask for an answer. Arctangent of negative 1. Arctangent just means find your tangent value where it equals negative 1. Once again, if you go to unit circle, it appears in two separate places. So this leads us to writing the same thing we did with cosine, but with tangent. And the reminder for that is our cotangent, where cotangent exists in quadrant 1 and 2, and tangent inverse exists in quadrant 1 and 4. So that means anytime you see tan inverse, you're only looking at quadrant 1 and quadrant 4. And what you're looking for is where is tangent equal to negative 1. Well, all our tangent values are positive in quadrant 1, negative in quadrant 4. Well, if we look right here, that would be where my tangent equals that negative 1. So it's going to be this angle. But just like sine, tangent does not exist, or tan inverse does not exist in quadrant 2 and 3. So that means rather than going all the way around, we have to go just down. So that's going to be, well, positive 45 degrees. This would be a negative 45 degrees. So that answer is going to be negative pi over 4 or negative 45 degrees. So inverses are just find that value on your unit circle and figure out what angle correlates to it. Yes, Gracie?
Can you just subtract 360?
You could, yep. Yep. And you get the same thing, right?
Yeah.
Yep. All right, so that is just the basis of sine of 60. Find the angle, find the value. Sine inverse is find that value, or take that given value and find the angle. So this goes from an angle to a value. This goes from a value to an angle. Now, let's talk about cosecant, cotangent, and secant. These are the only three that you have to worry about using reciprocals on, because cosecant, cotangent, and secant aren't on your unit circle right now. So you have to use reciprocals to put it on your unit circle. Once again, this is the only time you're going to use reciprocals. All right, so we have cosecant of 210. If I look at my unit circle, I'm going to once again note there's no cosecant on it. It's just cosine, sine, and tangent. So rather than looking for cosecant of 210, I'm instead going to look for its reciprocal. So that would be 1 over sine of 210 degrees. And that is because 1 over sine is equal to cosecant. Or in other words, sine equals 1 over cosecant, however you want to look at it. So we just have to put it 1 over sine of 210. Now we just look at our unit circle and find 210 degrees. That is right here. That's 7 pi over 6. What's my sine value there? It is negative 1/2. So plugging that in that equation, we are going to have 1 over a negative 1/2, which is just going to equal a negative 2. Cotangent of 7 pi over 6. Cotangent is not on my unit circle, so I have to use tangent. So that means I'm going to rewrite this as 1 over tangent of 7 pi over 6. Once again, we're just going to find 7 pi over 6 on our unit circle. 7 pi over 6 is right here. My tangent value is square root of 3 over 3. So that's just going to be 1 over square root of 3 over 3. Moving down, that would be 3 over square root of 3. You're not allowed to have a square root in the denominator, so you need to multiply the top and bottom by square root of 3. And that's going to give me 3 square root of 3 over 3, which is just going to equal square root of 3. Here's where it gets a little more tricky. And this is where people confuse these two things, because you're going to do a reciprocal down here as well. This is asking for the cosecant inverse of 2. Now, real quick, let's go back up to this little drawing here. If cosine's in quadrant 1 and 2, it works out that secant is also in quadrant 1 or 2. Sine is in 1 and 4, so that means cosecant will also be in 1 and 4. So let's go back to that problem. That problem says cosecant inverse of 2. Well, cosecant is not on our unit circle, but cosecant is the reciprocal of sine. Here's where it gets a little tricky. Here we took the reciprocal of whatever else he had. So it's 1 over sine of 210 degrees. This is where I said, when you have a reciprocal of an inverse, inverse tells you to do the reciprocal inside the parentheses. Inverse, you're going to do the reciprocal inside. So instead of 2, we're going to do the reciprocal of 2, which is 1 over 2. So cosecant inverse of 2 equals sine inverse of whatever's here, but take the reciprocal of it. In this case, it's 2, so we have 1/2. Now we just find 1/2 on our unit circle. Where is sine equal to 1/2? Well, sine is equal to 1/2 right here, and that's at 30 degrees, or pi over 6. Which equals 30 degrees, or pi over 6. All right, the last one is secant inverse of negative square root of 2. I need to write that in terms of cosine. So I'll have cosine inverse. If it's an inverse, we do the reciprocal inside. So that's negative square root of 1 over 2. As it's set up right now, negative 1 over 2 square root of 2 is not on our unit circle, but you can simplify that by multiplying the top and bottom by square root of 2. So I'm really looking for where is cosine inverse equal to negative square root of 2 over 2. Well, cosine inverse is quadrant 1 and 2. Where is it negative square root of 2 over 2? That would be 3 pi over 4. And let's put that down a little bit lower. Equals 3 pi over 4, or 135 degrees. All right, that's the nuts and bolts of how to use the unit circle with inverses. You have to know it. Don't lose a whole bunch of points. The first page, it's probably like near a quarter of your grade is knowing how to do this. All right? So if you don't know how to do this, you're looking at starting off at like a 75% right off the bat. So even if you crush everything else, you're still not doing well. Because look at all the points that are there. I'm looking for a unit circle, and I'm looking for that you can use all those values. All right, the next thing we're going to look at is graphing really quick. We're going to graph the sine of x, and then we're going to graph the cosecant of 2x. They go hand in hand. The graph of sine of x. Right now, the period didn't change, and we'll talk about the period in just a second. The period didn't change. If the period didn't change, that means we're going to count out 4 and put 2 pi, half. So we'll take 2 pi divided by 2 is pi, divided by 2 is pi over 2, times 3 is 3 pi over 2. That is our half multiplied by 3. It's the quickest way to write it. All right, sine and cosine, without being shifted up or down or being stretched, is going to bounce around between 1 and -1. So I'm going to mark them here so I don't have a super small graph. If I look at my unit circle, it can tell me how to start this. My sine value at 0 degrees is 0. So sine is going to start at the point 0, 0. So sine is going to start off at 0, 0. It's going to go up to 1, back down to 0, to -1, back to 0, and your graph's going to look something like that. Really quick, I had questions on it before, but just so you can see it, if I ask for cosine of x, cosine is going to be the red version. That is your cosine. But I didn't ask for that, but that would be what your cosine looked like. Our next one is cosecant of 2x. That number in front of the x affects the period. It affects the period because you're going to find the new period is 2 pi over whatever number that is, which is 2. 2 pi divided by 2 is just pi. This is the first step I would do every single time. Find the period, mark it on your x-axis. Since it's pi, I'm going to count out 4. 1, 2, 3, 4, and I'm going to write pi there. Then the quickest way is just take half of pi. In other words, take pi and multiply it by 1/2 and put that value here. So that's going to be pi over 2. Take half that, which is multiplying by 1/2. That's going to be pi over 4. Multiply that by 3, and you'll have 3 pi over 4. Half multiplied by 3. Easiest way to take care of your, or the period. All right, I have nothing happening with my amplitude, so it's still going to bounce around between 1 and -1. In order to graph cosecant, I'm going to first graph sine. If this was sine of 2x, it would look something like this. But I'm just going to put little tick marks because I'm not actually trying to graph sine. So that purple one is sine of 2x. In order to graph cosecant, what I'm going to do is every place that sine is 0, I'm going to put a vertical asymptote. And since it's a reciprocal, everywhere that's pointing down is going to point up. Let's use green. So my cosecant would actually be pointing up here, and wherever it's going up, I'm going to go down. And that green one is my cosecant of 2x. So in order to do cosecant, I have to draw sine first. In order to do secant, you would do cosine first. And just like sine, every place that was like this, we would just flip down. One more time. Cosecant, graph sine first, and just flip everything. And for secant, you graph cosine first, and you flip those. There's also tangent graphs in there and cotangents. We're not going to cover those in this lesson. All right, that leads us to a whole bunch of stuff happening to one equation. So if we look at that next thing, we have a times sine times the quantity b times the quantity x minus c plus d. The a affects our amplitude, it also reflects across the x-axis. If it's negative, it's going to go down instead of up. The B affects the period. C is our phase shift. Don't forget your phase shift actually goes kind of the opposite direction it looks. So if this is x minus 3, it'd actually go right 3. If it was x plus 3, it would go left 3. Up, down is just what it looks like. If it's plus 2, it goes up 2. If it's negative 2, it goes down 2. So I picked one of the more complicated ones because this one is not in the proper form. The proper form is you need to have a value times the quantity x minus c. We don't have that. We need to factor this 2 out of both of those spaces. So this is not in correct form yet. We need to rewrite it. So we're going to rewrite this as negative 2 times the quantity, I don't need that there. We'll say negative 2 times sine of, and we're factoring out a 2. So that means I want to divide a 2 out of this term, and I want to divide a 2 out of here. Well, 2x divided by 2 is just x, so I'll have 2 times quantity x minus pi over 2 divided by 2 to factor it out. It's just like multiplying by 1/2. So pi over 2 divided by 2, just like multiplying by 1/2, is going to be pi over 4. Close, close, and we still have the plus 1 outside. So that means we have a negative 2 out front, which is going to affect our amplitude, and it's going to flip the function. The next 2 affects the period. So the period is actually going to equal 2 pi over that 2. So it's just going to be pi just like the other one. It is going to go right, and it's going to go up. Whenever I'm graphing, I tackle the period first, because once I take care of that, I don't care about the period. So the period is count out 4, and whatever our period is, so it's 2 pi divided by 2, which is just pi. We count out 4, 1, 2, 3, 4, and we put pi. Then we go half, which would be pi over 2. Half of pi over 2 is pi over 4. 3 times pi over 4 is 3 pi over 4. The way I graph it, I always do the amplitude first. Everything has to do with the amplitude first, then I worry about going up, down, left, right last. So the amplitude right now is negative 2. So I'm just going to basically graph negative 2 sine of x. So I'm not going to take care of the up or down, left or right. I'm just going to take care of the amplitude. Well, let's go ahead and mark this as 1, 2, 3 on my y-axis. Let's mark this as negative 1, negative 2, negative 3. Sine. Regular sine starts at 0, 0, goes up 1, back down to here, back here. Well, 2 times sine is going to stretch our amplitude 2. So rather than going up 1, it's going to go up 2. Back down here, down to negative 2, back up here. Since it's negative, rather than going up 2, it's going to instead go down 2. So our just regular sine, not going left or right, is going to start at 0, 0, go down to negative 2, go back up to 0, up to 2, back here. And I'm just going to put tick marks on it because that's not my final graph. That is just negative 2 sine of 2x. Once I have the amplitude taken care of, I just have to go do my right, left, up, down. So this tells you to go right, pi over 4, and up 1. So you're going to take every point. So we take that 0, 0, 1. Let's go in green. We are going to shift right, pi over 4, and go up 1 point with it. Go right and up. Go right and up, right, up, right, up. And the one in green is our final answer. Oop. That's our final graph. If you're not super strong grapher, you may have to do more steps than that. You may have to do your original sign, then you might have to do 2 sign, then you might have to do the -2. You might have to break it apart into more steps than that. Like I said, this was not a lesson to teach you from square one to now you're a master of it. It's just a quick reference on how to do key aspects of it, knowing that this is a huge part of the test. All right, what we kind of covered here is probably close to a quarter or something of our test. So if you can crush this and knock it out of the ballpark, you have pretty much a quarter of the test done. But my guess is several you have to look over your notes to review how to do inverses, how to graph tangent, stuff like that. All right, any questions for me?